Hello and welcome to today's session on Metallurgical Engineering and Material Sciences. I am Tejas Sumar Sham, your instructor for today. I've done my BTech and MTech from IIT Bombay, and it's my pleasure to be talking to such a young, talented batch like you guys. I'm sure we'll have a fun time together. In today's lecture, we'll be dealing with manufacturing processes. Manufacturing processes is basically the section of metallurgical engineering and material sciences that deals with making things. Making what things? Making castings, joining two metals, joining two parts, shaping them in terms of machining them, making parts using powder metallurgical techniques, and finally deforming parts and making something out of them, deforming metal sheets, deforming tubes, and making parts out of those things. So under manufacturing processes, we shall be, in the course of a few lectures, covering the following topics. The first one being casting. Casting is one of the most important aspects of metallurgy, because with casting we make a lot of the things that you have today. Most of the ferrous and non-ferrous materials are today shaped or made primarily using castings. What is casting? Basically, casting consists of two steps. The first one being melting a material, making it molten, and the second one being pouring the molten material into a mold or a container so that this molten material takes the shape of the container. That shape is called as the cast shape, and hence the name casting. After casting, we will move on to one more very important aspect of manufacturing processes, which is called joining. Has any one of you heard of joining before? I'm sure you must have, in some form or the other. If not by the name, you must have heard it implicitly. Can you tell me what is the example of joining? Any one example will do. Yeah, go ahead. Okay. Joining welding. Yes, welding is one of the parts. Are there different types of welding? Yes, you ma'am. Yes, of course there are. We all know that, don't we? I'm sure you all recollect fairly well that joining has got three major parts, and we will deal with all three parts in quite an amount of detail. The first one being soldering. What is soldering? Oh, many a times when you have those watches, haven't you seen some parts popping out and going to the watch wala and he taking a small little machine with the tip like a pin which is heated up and joining two components, or maybe on a PCB many of you guys must have seen how components are soldered on. Soldering is basically a low temperature process in which two things are joined together by local application of heat. After soldering, we shall look at brazing. Brazing is nothing but a high temperature version of soldering. So in soldering, we typically deal with temperatures in a certain low range, maybe up to 200, 250. We'll see the exact details as we come to it. But for a rough idea, say 250 degrees centigrade, 300 degrees centigrade. Brazing, on the other hand, will go up to about 800 degrees centigrade. So when you braze two materials, you can apply heat, which will take it to about 800 degrees centigrade. Of course, remember, both of these have to join two materials. The materials can be the same type, they can be different types, but they have to be joinable. Finally, we come to the third and probably the most important type of joining from the perspective of the GATE exam, which is welding. Welding, among the three, is the highest temperature process. In this temperature process, what actually happens is that you have two materials, or you have a base material and a material to be welded. You apply heat using different heat sources. You may use a flame gun, you may sometimes use an oxyacetylene torch, you may use an electric arc welding, you may use a gas tungsten arc welding. So yeah, there are a lot of different types of weldings that are available to you. The underlying principle being that you join two materials using the highest temperature among the three processes. In welding, you can also have solid state welding and you can have liquid, that's fusion welding, and solid state welding. So we will deal with both of these. Solid state and fusion. Fusion is basically when the material converts to liquid. Solid state is a form of welding wherein per se the material does not melt. The welding is carried out by plastic deformation, which basically joins two materials together. And one example of this is friction welding. In friction welding you have solid state welding. Of course, we'll come to the details when we see it. Now, can you think of any other manufacturing processes? Yes, go ahead. Yeah, you're right. The third process we will be dealing with is mechanical working. What is mechanical working? Mechanical working is nothing but taking a material and deforming it under application of certain loads or stresses or strains or strain rates. What consequently happens? The material gets bent. How many times have we seen in real life, take a wire and bend it, it bends? Or take any one of these small metallic appliances, you may have a metallic strip or something and just bend it for the fun of it, a ruler maybe, and it deforms and it doesn't come back to its original shape. If it comes back to its original shape, it still undergoes a little bit of work, mind you, but we won't deal with those kind of elastic deformations more in mechanical working. We will deal more with something called as plastic deformations. What is plastic deformations? Plastic deformations are of two types. One is a hot deformation and the other is a cold deformation. Hot deformation happens when the material to be deformed is deformed under the application of heat. Cold deformation, on the other hand, happens when you simply deform the material without adding any external heat source. After looking at these three important things, we will then move on to look at another extremely critical manufacturing process. Can you guess? Yeah guys, come on, think. It's not that difficult. You already have casting, joining, mechanical working, and you need one more process which is extremely critical, especially in industry. Yes sir, go ahead. Yeah, absolutely right. We're going to deal with powder metallurgy. So I'll just erase off the heading and I'll put powder metallurgy right at the top. What is powder metallurgy, guys? Yes, absolutely. Powder metallurgy is the process through which we can make ceramic components. Why ceramic components using powder metallurgy? Simply because ceramic components have, or ceramics are very high melting materials, and heating them up or melting them in liquid form is not really possible. So what we need to do is we need to make small little tiny pieces of the material called powders, and those powders we need to process using powder metallurgy techniques. There are several powder metallurgy techniques to make components. Can you think of one? Yes, slip casting is one. What else? Can't think of any? No problem, we'll come to it. What are the parts that are manufactured using powder metallurgy? Anyone? Okay, dental implants is one. What else? Turbine blades? Yeah, turbine blades are manufactured using powder metallurgy techniques. Okay, what else? Ceramic ball bearings? Absolutely, yeah. So the uses of powder metallurgy basically here are tremendous. And in today's world, powder metallurgy is one of the most important areas where we need to focus, and we will give adequate, stress on this topic. Finally, towards the end, there is one small topic which is also used for manufacturing processes, material shaping, and that is called machining. Now, machining, as the name suggests, is nothing but using a machine to cut the parts that you manufacture using the other, processes, or make processes using tools which will actually cut a block of metal or shape the block of metal directly in a machine. For example, you can have a cast piece which has a very rough surface, and you want to get rid of the rough surface, so you say, hey, let's put it in a machine and chop off the surfaces. That, my dear friends, is called machining. While we shall not deal with machining in great detail individually, we will touch upon machining as part and as parcel of these other four techniques. So let's begin off with this introduction. Let's start with the first topic, casting. So while I erase the board, casting is one of the most industrially important techniques, let me remind you, and hence we need to all focus on this particular technique. What exactly does casting do? Very simple. In a layman's technology, casting helps us create parts or objects or shapes using molten metals, which are then poured. This is, in short, what casting is all about. Let's go into a little more detail about casting. Why do we need to use casting? Why can't we simply take a block and start chopping it off? Any guesses? Yeah, absolutely correct. So what happens is, when I have a block and when I try and say make an intricate shape out of this block, if I have to make this particular shape, observe that these are sharp corners and this is a flat area. The shape, there are a lot of contours on the surface. Taking a block, taking a saw, taking a machine and cutting out these parts is not very easy. Further, go on to imagine if each of these parts had a small modification. So if I had a shape like this, pardon my drawing, it's not the best, but it's not that bad either. So if I had a shape like this, making these steps intricately while not cutting this becomes a slight problem. So for manufacture of intricate shapes, it's always easier to use casting. More importantly, casting helps in bulk manufacture, and helps in quick manufacture. As compared to the other techniques. So with that, the introduction to casting, we end this particular session, and the next particular session we will come back and deal extensively with casting. Till then, have a great day. Bye-bye.